I don't say this very often, but good morning. And I hope if you're here from one of the world's bigger hardware companies, as many people are, I have absolutely nothing to teach you, because this talk is mostly aimed at people, I suppose like me, who've been either doing hardware for a few years or whose companies are mostly software focused, and who want to learn a little bit about how the hardware industry works and how to commercially, technically make a new product and the things to look out for if you're doing it for the first time. So the running order goes a bit like this, and I'm glad that works. I'm using the word we as well. Should we do it? How should we do it? And I'm using that because all my talks so far have been aid memoirs to get things into my own fat head, so I hope I learned something too. So should we do it? Should we make hardware? How should we do it? What are the processes? What's going to be different about it from software? Assuming we already know how to make software. And number 3 is expensive lessons that I've learned that I feel I've paid for, so I should share with people. And the background to this slide is clearly me making a batch of head trackers. Before we go any further with the talk, I also want to say that there are a few things in this talk, because we've only got an hour rather than a whole year, that are out of scope. So I'm not going to talk about the things that happen when you are a software company and you start making hardware. One thing you would expect is a much higher head count because you're moving physical stuff about the world, because your life is a lot more complicated from a legal point of view, all of that stuff. So we're not talking about that. We're not talking about logistics, even though there'll be somebody and possibly a team in your company that just moves stuff around. Consignment, so components go to a country that makes your stuff. Stuff goes from that country to your distribution warehouses. Stuff that doesn't work goes back somehow, and you get feedback on that, and all of that's terribly complicated. And it seems quite well paid because no one wants to do it. Specific details about hardware design, so I'm not going to talk about circuitry. You need to find somebody competent who can do that, if only to look over your own design. And I'm not going to talk about the legal stuff and the other hidden costs and the race to compliance and certification and paying large companies an awful lot of money just so you can use USB. That's sort of out of scope. So without further ado, should we do it? Now, when I started making my head tracker and started my own business, I had a lot of conversations like this, and most of them in words. This is the only email thread I can find. But everybody says the same thing. I say everybody. Most companies that have done hardware before will say something along these lines. We've done it before. The software we make is marginal at worst and slightly profitable at best. Every time we've tried making hardware, we lose a ton of money. And it's a very familiar story. And for that reason, if nothing else, I think my golden rule has to be for this project, just don't. And I'm going to qualify that because otherwise this is going to be a very short talk. So the first reason not to is the opportunity cost alone. Hardware projects take so much longer and cost so much more than you think they're going to cost and take at the beginning of them. Even if you factor in that it's going to take far longer than you think it's going to take, it takes even longer than that. And I'll touch on that again in a bit. So the opportunity cost is very high. You could be doing other things and living a happy life. Second thing is, if you have a technical question you need to answer with hardware, there may be a way that you can concoct something, like a really bad lo-fi user experiment with a bunch of interfaces and a few buttons and some gaffer tape. And that might just be all you need to evaluate your idea and decide whether or not it's got legs, and whether or not there's a market for it, and whether or not those customers that you think you've got are going to pay you any money for it. Of course, there's a big asterisk next to this, and the asterisk is what this talk is all about, the sort of but, unless. And actually, I've already subverted my own talk for 2 reasons. The first is that there's been a picture of me on slide 2 actually making head trackers. And the second thing is I'm wearing a T-shirt that a friend made me, so I've actually embodied my message in hardware and made physical stuff to tell you not to make physical stuff. So we'll unpack that in a bit. This talk will become clearer. So let's start with the not just don't. Perhaps the oldest piece of advice from an industrialist and a socialist that's worth reading is a very famous quote by William Morris, who was an artist and who owned factories, and who's made it his mission in the late Victorian period to make beautiful stuff democratically available to people who wanted it, so that they could have good art and good commodity art. He said something quite, this is the quote, "Have nothing in your houses that you do not know to be useful or believe to be beautiful," is one of the things he's best remembered for. And he said it as part of this very long speech that he delivered to people who were making domestic art, things like wallpaper, things like furniture. So he was addressing this to manufacturers. This was his rule for people, and the idea was it would just lead to better stuff and much less trash. But actually, nobody has really said anything more about whether or not you should do something than does it have beauty and does it have utility? And there may be other aspects to a product that make it appealing, such as originality or novelty, but actually, even those things have to serve the purpose of utility and beauty. Now, there is a big problem with utility and beauty. The first thing about utility is your customers aren't everybody in the world. So some people are going to see a very useful product and have no use for it at all. So it's in the eye of the customer segment that you have to target. The problem with beauty, of course, is it's in the eye of the beholder. So even in your customer segment, not everybody is going to get what you do. But there is no real better test for whether or not to make something than does it fulfill the criteria of utility and beauty. That's the most basic philosophy. And of course, we spent the last 135 years making life more complicated for ourselves. I want to reference a recent book by a friend of mine called Matt Watkinson. And he was considering what, taking a company as a whole, are the important things to consider before doing anything strategic, making any change, spending money on anything that's going to cost money, really. And he designed a sort of 3x3 grid of everything, really, that a company needs to watch out for. And utility and beauty are kind of this square in the top left-hand corner, customer needs. Is it desirable? But then there's a whole other grid of things that you also need to consider when you make a product and spend money, which is the product market fit. And by market, he really means competitors, even though it's a sort of subset of what a market is. So does it fit well in the marketplace? Is somebody going to come and steal your bread? Is somebody going to see you out of existence? All these things, intellectual property, rivalry, and so on. And also, very importantly, the product organization fit. Does it make sense in the portfolio of what you're trying to do to put this out in the world? And so those, and on the vertical axis, the things you have to consider, so desirability is important. And almost always when you want to make an audio product, it's because you think it's going to be desirable. So usually the top left-hand corner is taken care of. But then there's also profitability, which is very tricky. There are always hidden costs in development. Things often cost more than you think they're going to cost. And just look at the last 2 years. And longevity. So do you have the mechanism in place where your product is going to make money for as long as it needs to make money in order for it to have been worthwhile? So that book is worth reading. Although ironically, Matt pointed out that the people who buy that book are generally the people who are thoughtful enough not to really need it, and the people who really need that book are too proud to buy it. But it is a very good book. And let's go back in time 2,500 years and have a look at the 1611 King James Bible. If you've not read the book of Ecclesiastes, even if you're not religious, it's probably the first really good business consultation tome. So I've got chapter 11 out here, and chapter 11 says the opposite of just don't, so I'm going to read this and not in Middle English. If the clouds be full of rain, they empty themselves upon the earth, and if the tree falls towards the south or towards the north, and the place where a tree falls, there it shall be. He that observes the wind shall not sow, and he that regards the clouds shall not reap. And later on, in the morning sow thy seed, and in the evening withhold not thy hand, for thou knowest not what shall prosper, either this or that, or whether they both shall be alike good. So, they're telling you to just make stuff. Although Ecclesiastes also says in chapter 1, everything is futile and there's nothing new under the sun. So it is quite a sobering read, but apparently King Solomon, or whoever wrote Ecclesiastes, is advocating that we do go ahead with this. So philosophical digression. Burnt into the title of my talk, How to Make Hardware Without Losing Your Shirt, is the implication that we already know what we want to achieve. We don't want to lose our shirts. The thing about success is it could be measured in any way. We could have predictions. We might have return on investment projections that we want to fulfill. It might be post-hoc. We may just look at the project after it's gone out and gone well. We're not quite sure what we wanted to set out to achieve, but it's done all these things. It's created these opportunities for us. It's moved our company along, and therefore it's been a success. And actually, all success tends to be measured and rationalized post-hoc, because that's how our minds work as human beings. Financial versus intangible. It's almost become a cliche in Hollywood now for an actor who's been in a flop film to say, well, actually, we think it was an artistic success. And Hollywood is quite brutal because the box office count is what? Sort of 2 weeks after a picture comes out. Then all the other money it makes doesn't really count. So you can have a flop that people are still watching in 25 years' time and has actually made money, but it's still considered a flop. So nobody really knows how to measure financial return. And quite a lot of the benefit of doing anything is intangible. Does it lead to the next gig? Does it keep you alive? Market versus organization. So you may deliberately put out some kind of halo product that has very limited appeal, that isn't intended to give you money, but is intended to reflect some kind of cast some kind of shadow on other things that you're trying to do or move you into a different segment. And that can also be a definition of success. Even if it's only designed to break even or make a modest loss, it can still be counted as your marketing budget, essentially. And short-term versus strategic, which I don't really need to talk about because it's a continuum. So all these ways of measuring success, and we need to figure out what success is. Basically, it's always going to be post hoc, and you just need to keep an eye on the data so you're not deluding yourself. But anyway, that's a sticking point that we really need to get straight, and I don't have any more answers than that. So the only real indication, or the only real thing you can control at the beginning of a product is to set a stake and think like a venture capitalist. If I lose the money I pile into this project, can I get up and give the wheel another spin? The answer always has to be yes. You don't bet the farm on a gamble like this. And all VCs will do this. They will decide to invest in a company, and they will then decide if that money is thrown away. And they might be able to do a few things to adjust the odds of the bet after they place it, but generally they don't do that much. They just move on and place another bet. And it's a very productive way of thinking because, after all, success is a numbers game. You just have to make sure you have enough of a buffer to keep throwing things at the target. And making cleverer mistakes as you learn. So how should we do this? This is how your project might look as you're running it. It's very much how a software project looks, and this is a very heavily labeled political diagram, so let's put the labels in. You're trying to get your customers, right? And in your way are competitors and vested interests. And if you're working in making hardware rather than software, those vested interests are a lot bigger because you're having to keep things in other people's shops. And the physical world becomes a new challenge because the physical world won't take your dreaming and it won't take any stock of what you're trying to do or how nice you are. It will steadfastly refuse to bend to your will. And you have management who will sometimes protect you from this and will sometimes be elsewhere. And you and your team spending your budget trying to get to your customers before the ammo runs out. That's not generally how project managers see the world. Project managers like to see the world on the time axis. And so generally, if you look at Prince2, essentially what you're trying to do is take an idea with an awful lot of risk, your little castle in the sky, and eventually as the project moves on, and we progress along this x-axis, you get to a lorry here and you ship, and that's how this wonderful abstraction looks like. So as you move on, there might be bumps in the road, but you're trying to get nicely from your idea to the lorry. And if you're using a waterfall project management system, and you have a clear sign of light to the end, clear line of sight to the end, I haven't slept. What you need to do is specify first, so you know what you're making at the beginning of the project, and then everything else is just execution. You're getting your engineers to build it, they refine it, it gets validated, gets produced, and it ends up in the van, and at the end, if you're very lucky and your company really cares about what it's doing, you have this whole support thing throughout the product's life, where you're making it better and you're keeping customers happy. And if you're doing Agile, it looks a little bit different. You have this Agile loop in the middle. And these projects are good for things in a complex world, things where you don't have a clear line of sight from the beginning to the end. And things where your market is so complicated that you want to keep putting out offerings. And it works only if the friction in the Agile loop is small enough that the cost of deployment is nice and low, and the cost of reiterating is nice and low. Hardware generally doesn't work so well like this as software. And actually, I want to point out that these are both fictions, because what actually always happens in a practical project looks more like this. So we're always sort of weighing up price versus feature, and then bloody everything goes wrong. You move up and down the risk thing, your time goes forwards and backwards, and in the end, everyone is exhausted, and we don't know actually if you're going to get to the lorry, because quite often, the aim of a project like this is to move around the diagram and get to this. And this is very important, the successful experiment, unsuccessful product box. The most expensive thing you can do if you are running a company is not having your engineers sitting around doing nothing, and it's not even throwing expensive parties. It's executing and shipping and supporting the wrong product. Because just getting a product out there in sufficient quantities is likely to cost you millions. Millions you don't need to spend. You can have a party and it costs less than millions, unless you're focused right. Gosh, I wish I kept the shares. In fact, I wish I had the shares. I left a bit too early. Anyway, yes, and hardware trouble of all kinds. So if you're making hardware, particularly the dev tools don't work, the prototype blows up, that's a big box. You can spend half a day just fixing your bloody monitor no matter what you're trying to do. So these things happen. I've got the arpeggiator button up there as a last lousy feature because that's currently close to my heart. I was designing a modular synthesizer for somebody, and 2 months into their project, somebody said, why doesn't it have an arpeggiator button? Now, who here has implemented an arpeggiator? Quick show of hands. There's quite a few, like sort of 15% of people here. And I hope I'm not speaking out of turn when I say that it kind of doubles the complicatedness of your product. It's horrible, real-time sequencing and syncing to a number of different sources and then falling back in a way that people will expect it to fall back and being musical and having all those little edge cases taken care of. So everything just sort of doubles in complexity because they missed a bloody button off the spec. That happens a lot. This one seems to happen a lot to me, EMC, ESD problems. So before you can legally sell a product, it's got to go into a test chamber and you've got to make sure it doesn't emit loads of radio frequency energy. The problem with most audio products is you're coupling really sensitive power supplies with a lot of high-speed digital electronics, and it's really, really hard to uncouple all the radio stuff that just happens from everything else. So your product is either quiet, audio quiet, or it's radio frequency quiet, and trying to find that compromise is often a very expensive endeavor. And that can add a few £1,000s in a few months to your project too. So all of these things have befallen me. Doesn't meet competitive spec as an interesting one. Obviously, if you're making something like an audio interface, people will read the spec sheets. If you're doing something a little more niche, then generally speaking, they won't, except in some markets. And sometimes, you can do something that's quite lovely and appealing, but the signal-to-noise ratio means you'll never sell it in Germany. So, yeah, all of these things. Oh, the now it's 2 projects box is quite fun as well. If you know what you're doing, that happens quite a lot. It's often a good thing to do, where you park half of your features and decide to go after a smaller customer base. So all of this happens, and probably more. I'm sure there are things in everybody's minds that aren't on this diagram that have held them up in the past. So I haven't really spoken about how we should do this yet. I've just spoken about what happens. So let's move on. So I intimated that this arrow is the important one between respecify and build. So in hardware and software, all this stuff is quite easy and non-frictionless. We can test that build, and we have a team to do that. We can know where it goes wrong. We can respecify. All of the friction in hardware is about physically making stuff, adjusting printed circuit boards, getting them made, getting the components made, sticking them all together, reiterating that design. And often with a mechanical design, retooling if you're a bit further down. It's expensive and it's time-consuming, and this is the thing that's going to cost you money and take you time. So the rest of the talk really is about how we mitigate that. The first thing I need to say is if you're doing a project of any degree of sophistication, just throw away 2 years. That's how long it's going to take. If you're a well-established audio company and you're doing something that you already have a very good idea of how to do, that might be slightly different. But I've been involved with no project from a company that's entering audio for the first time that's taken less than 2 years, really. And it takes that long to refine what you're trying to do. It takes that long to make a really well-executed product and knock the gremlins out of it. It's going to be 2 years. And I've formulated a thing that I've named after a former manager of mine, a Focusrite called Dave Hodder, and he doesn't know I've done this. But Hodder's law. Now, the thing about Focusrite is, as we were getting more sophisticated, he was running the R&D team, and we started doing time sheeting and Agile stuff, and he was processing some of the early data. And he noticed a trend in the data. So you expect that as project complexity increases, the amount of time it takes to complete a project goes up as well, and it does. But what's really interesting is this DC offset. And he discovered that, and this is quite a whimsical conclusion, but it does seem to hold, that a zero complexity project where you've got a team of engineers doing nothing and delivering nothing will still take 3 months. That's just a communications overhead. That's having meetings. That's fixing your monitor when it breaks. All that stuff just takes 3 months of your engineer's time. It just seems to work out that way. But it's a very sobering thought that you can probably deliver absolutely nothing in 3 months, even if that's what you intended to do. So the first thing to do to reduce friction is to remove dependencies on mechanical design. And I'll qualify this a bit by, this is a page from the Designed in Apple by California book, that sort of $200 coffee table book that they bought at Rolly, so I snapped this page with my phone. I wish I'd taken a better quality picture. I didn't know I was going to use it in a talk, but that was several years ago. This is the prototype Apple Watch. And I show this because it's a really good example of everything you should do right when making a prototype. The first thing is it doesn't look like an Apple Watch. They've sort of exploded and laid it out on the table, and that's great for several reasons. It's great because every time you want to change and tinker with the form, you don't need to go back and change this bloody thing. It's good because it's got physical ballast, and it can sit on somebody's desk, and they can plug in a debugging harness, and when they get up to go to the loo, it doesn't all end up on the floor. So physical mass is also quite important. They've used a silk screen layer to describe things. These controls here, this digital crown and these two buttons, of course, didn't end up in the final product. They weren't interested in prototyping the crown here. They were interested in prototyping interaction. So they've got these ugly buttons. And they've got probably one more than they actually ended up using. Debugging connectors everywhere. You've got ports that plug into the computer up there that don't make the final watch. As soon as you decouple the physical world or the looks-like prototype from the works-like prototype, you make your life a lot easier. You're not trying to hit two targets at once. So that's a very important thing to do. And the second thing, it's becoming increasingly obvious that actually, if you're doing small pieces of hardware, it's much easier to iterate the physical design with things like 3D printers. I mean, look how bloody cheap that is. It's far easier to iterate the mechanical design than it is to iterate the electronics design. And now, generally speaking, the electronics design is the slow and lumbering and expensive thing to change. And if you want to make some alteration to the case, it can actually be done overnight. So that's worth thinking about. Next thing to do is reduce size. Now, if you were designing a piano mechanism, you wouldn't do 88 keys at once, because every time you wanted to make a change, it would take you a day, at least, probably longer. Piano technicians train on these single key or sometimes double key, if you want to know how a black key works, piano mechanism things. Piano actions, I think they're called. And one can buy these. And if you're designing a new piano mechanism, you'll probably want to get one key right first. And the same was true with, for example, the C-board, where we're designing a new sensor technology. This lived on the desks of product demonstrators, of sound designers, of the engineers doing pretty much every aspect of this for months. And so everybody got one of these, and it was a single octave C-board. And the advantage of this is that it's relatively small. Actually, it's quite large. It's a sort of A2 piece of paper size, so about this big. But it's smaller than it would be to have a C-board in everybody's desk, so that makes it cheaper. It's easy to iterate it, so we can reprint silicon, and the silicon takes a while to mold, but you don't need to mold a meter of it at once. So again, things get cheaper. It tells you everything you really need to know about prototyping the interactions as well. If it feels wrong, we can have another go. It just means you can move faster. I will say, though, that acrylic is a terrible material to make this stuff out of. It doesn't take a thread, and it scratches, and it cracks, and it's bloody horrible, so try not to use acrylic. I'm actually indebted to a chap called Gaetano Ling, who worked on the mechanical design team, for remembering to take a photograph of this. I think it might be the only one in existence, and it's on his portfolio website. Next thing to do, of course, is to reduce complexity, and do this systemically as part of how you do products. Isolate risky or hard elements, refine them separately to iterate faster. So almost always, if you're trying to do something clever with power supplies, like make a 48-volt power supply out of USB, or make a bipolar 9-volt power supply out of USB, things like that, they're always prone to sensitive little loops. They never work at the first time round. They sometimes even catch fire. And things like that, where you know there's going to be a problem, or you've gone through a couple of prototype spins and you still haven't got it right, just break it out of the board. It's a cheap way of doing it. It's far easier to make a small 2-layer board and solve the 20 components on which your own engineer can do in a day than deal with huge boards with 400 or 500 components on. So it should be obvious, but it never really seems to be. And of course, it helps if you decouple works-like and looks-like prototypes to do that. Pair features mercilessly. Now, if you're in software, this is really important because it's counterintuitive. Because you can do so much with software and because it controls the experience, the temptation is to keep adding features to increase your reach and improve the appeal of your product to more and more customers. The opposite is actually true in hardware. What you really want to do is you want to take off as many features as you possibly can. You actually want to limit the appeal to customers to a certain really acutely targeted market. And one of the main reasons for doing this, I'm friends with a neuroscientist, and we've had these discussions while 1 or 2 glasses of wine in. And it's very hard to find any data or citation for this, but we were trying to work out the fast part of the brain, the sort of mammalian part that clings around the base, clings around the brain stem, and it's responsible for our kind of emotional regulations. That's sort of what politicians talk to. The 3-word phrases are very much because you're talking to that. The physicality of a product and the initial sense of appeal and whether you like it or not is also directed at this part of the brain. And we were trying to work out how many neurons, if we were trying to model this, we would need. And the best information he could come out with from the reading he did was it is about the same complexity as a small mammal, a mouse, for example. So actually, when you're showing people products, you're talking to mice. And the purchasing decision is often made by that mouse brain and then post-rationalized later. So you really want to provide a very distilled, simple offering, not make people think, not over-encumber it with features. And I'll talk about that a little bit later when I've got another slide up. Third thing to do, obviously, because we're all engineers, is to design in dialogue with them. A very good example of this was when Focusrite started making the RedNet series. The industrial designer decided he liked the sort of red matrix LED displays, the old school ones from the old Red series, and he put them on there. And the project manager complained that these things now cost like $12 or $15, and all you got out of them was 6 lousy characters. And when I worked at a console manufacturer, we were buying full-color OLED displays for about $6. And I suggested to him we use one of those. And of course, it was a no-brainer. One of those just ended up in the product, but nobody would have known about it had an engineer not been able to feed back into it. This happens all the time. You might want to add a button and an engineer will have a better idea. And they'll know how complex it is and how long it's going to take them to implement. So that's also quite important. I'm just putting this up because it's a good video, but it shows Tesla getting 3 things absolutely right. It's made by a mechanical engineer who's really into Tesla. And it shows the progress of this door handle, which started out being something that was notorious for unreliability. And it shows a later revision where they've simplified it, they've got rid of all those wires, and it's basically a motor and a single sensor. And a lot of slightly clever software, but less to break. And it shows, the things it shows about Tesla is, firstly, they've set aside time and a budget to do product improvement continually. Now, not many companies do that, and that's important. And the second really interesting thing it says about Tesla is they managed to do a difficult thing that even fewer companies can do, which is close a feedback loop between the customer and the engineers. And very often those things are open loops. You deploy, and then you forget about a product, and you have yield problems, and costs go up, and parts go out of stock. And you never tell the engineers about it until it becomes a company-killing problem. But if you manage to close that feedback loop and you dedicate time and resources to servicing things, you can save cost, you can increase yield, you can improve reliability in the field. So trying to close that feedback loop and doing it successfully is a hallmark of a really great company. Companies that care about maintenance for years after they ship. Companies where the last product off the production line looks nothing inside like the first product, but does the same thing, but for cheaper or more reliably. These things are the hallmark of doing hardware well. So you have to be in it for the long haul, really. Another demonstration of this is a really old, slightly crappy video that we did pretty much as a joke at Novation. We wanted to show somebody that we'd got a touch sensor working, but I was casting around for an example from earlier on in my career, and that's my 32-year-old hands. But clearly what we'd done, we were making a DJ controller with a touch sensor in, and we'd separate, this is a key membrane from an Octane, so we just ripped it off a product we already had. We're clearly prototyping interactions on something that looks nothing like the finished product, on a board with very few components on it, just so that we can get the touch sensor right. And up here, I'd completely forgot we were doing this, but there's some carbon-printed velocity-sensitive pads. We were clearly looking into the next kind of rounds of launch pads and the SL pads and trying to find a way of making them effectively and efficiently velocity-sensitive. So all of these things from all of these different products we were testing on one board. And it didn't matter if it broke, and we could throw it away, and we could do another one in 2 weeks. And that's because that's the right way of doing it. You don't want to spend thousands of pounds every time that something doesn't quite work. And this is just a little piece of evidence that I found to back up my claim that you should make a product as simple as possible. It's a fairly good paper. It's a little bit nuanced, but I've highlighted over-featuring and being forced to consult manuals also appears to cause negative emotional experiences. Implications of these findings are discussed. Now, in the implications of these findings, I say a very interesting thing, which is that the initial appeal of a product is often based on how many features it has. But then when customers get to use it after a few weeks, if there are too many features, it frustrates the hell out of them and they hate it. So if you want a customer to really love a product, again, it's got to be pared down and targeted. If you're the first to market with a new piece of technology, then great, because you get to dictate this conversation. There's nothing else like it. It can have no features. You can make it a perfect distillation of what you're trying to achieve, and then you can let everybody else fail with featureism. So that's an interesting paper to look at. And it's fairly accessibly written as well, which is why I photographed it when I found it. Next thing you can reduce is quantity during prototyping. And sprints usually look like this. You first decide on the questions you're trying to answer. So we've done William Morris's utility and beauty. There's also things like marketability, practicability, everything from that grid that we saw at the beginning. And of course, what is the least we can get away with doing? can we do this without making hardware? Because it's much cheaper to do that. Next thing is a build 3 sprints, and I'll tell you why I'm saying 3 later, but you need to build at least 3 units. And most of your iterations can be done by building no more than 3 units, probably exactly 3 units. And these things scale in cost, not quite linearly, but it's much cheaper to make 3 than it is to make 10. The great thing about making 3 is you can pretty much build them in-house using a soldering iron most of the time. It removes your dependencies on contractors. It removes your dependencies on very often getting things like stencil masks into the factory, into your office, and all of the gubbins that you need to prototype. Next thing is building 30 sprints, and this is Valley of Despair I want to talk about because I've mentioned it. Valley of Despair is what I call the feeling when you power up a version 1 product and you are immediately hit with what a crap engineer you are. And if you're lucky, it doesn't catch fire. And if you're even luckier, most of the features work. And if you're extremely lucky, it doesn't buzz like a bastard. So crossing the Valley of Despair is a very sobering and important thing to do. And that's why you don't build more than 3 of an issue 1 product, because there is no guarantee it's going to work. You're often just building them to throw away, and it's terrible for the environment, and it's terrible for your ego, and it's just terrible for a number of reasons. So most of your sprints should be build 3 sprints. You can move quite quickly. Build 30 sprints are also important because then you get the supply chain involved, and you get to see where your yield problems are. Then you have to start thinking about things like automated test procedures. And so you need a few of those once you're more confident that your product is going to work. Once you're doing things like getting initial customer and reviewer feedback and sending these things out, 30 is a good number to build. By the time you're building 300, you really need to be in production. You only want to build 300 once. And then the next batch of 300 you build is going to be the second batch you're going to actually sell for money. So build 3 sprints are very important. Notes on building 3 units. I say 3, and 3 seems to be the magic number. You need 1 unit that's always sitting on an engineer's desk and is never ready for demos. You want that to remain. You want that not to leave your engineering premises. You want a 2nd unit with the last decent demo running on it that people can show to other people. That goes to marketing. That goes to those secret talks that you have with third parties about what you're working on. And you need a 3rd unit, which is your YOLO unit, which you're going to blow up, which you might throw away, which you might give to a mechanical designer to drill holes in. But you almost always must throw one away. And even if it doesn't catch fire, there are very often things that go wrong in hardware where you want a unit to compare against, to know if it's the design or the implementation or just some specific thing about a pin not being soldered. And those investigations can save you days. If you do something to a unit and it breaks the unit, then you do something to another unit and it breaks that unit too, you know it's the thing you've done that's the problem, and not the fact that you got up too quickly to go to the loo and knock the prototype on the floor. These things save you days of anguish. So build at least 3. You might want to build more than 3 because your team is big enough that you need some more on people's desks, but 3 seems to be the right number. Other thing I want to talk about is company politics. You'll have one for engineering that's always broken and always sitting on a desk, and you'll leave the room to go to a meeting, and you'll come back and you'll find that somebody's shipped it to Boston. This happened wherever I was. This happened at Focusrite, this happened at Rolly, this even happened at a console manufacturer I used to be at called Kadak. You'd come back from wherever it was you were and you'd find that your desk was clear. And it was some sort of strange political dick waving going on in the sales and marketing team, and it just ended up at a conference somewhere and you couldn't do any work for 2 weeks. The best solution I found to this problem was a packet of Hello Kitty stickers. So cover your unit in these non-removable stickers. Make it look cute, make it look horrible. But defacing it in this way does 2 things. Firstly, it stops people trying to show your units to the outside world, so it will stay on your desk. I am Seaboard. Do not remove what else. The second thing this does is stops your industrial designer being able to enter the room without covering his eyes. There was a very sensitive chap who hated this, and he couldn't be in the same room with it. But it got the job done. These never ended up being photographed. These never ended up in Boston. Hello Kitty stickers, engineer's best weapon. Focusrite tried to reverse this logic once, and it didn't work very well. The sales and marketing team said, put this sticker on your unit if you don't want it to leave the building. And of course, within 2 or 3 hours, every single prototype we could find had a gold sticker on it. It's just, this is the only way that make your unit look horrible. It's the only solution. And now I'm going to do some expensive lessons because they are so expensive, I feel I need to pass them on. So a couple more principles to uncover. The first is find your people. And For some reason, I've not seen this expressed so succinctly in any book I've read. But I made a friend a few years ago who's a very good business person who and it's pretty much her motto: find your people. And I've made this mistake, and it's cost me a lot of money, so I'm going to communicate it with you. Okay, I have here a prop. This prop, this doorstop cost me £4,000, and it's a doorstop. I can't use it. Absolutely worthless. But I can now do the Richard Feynman thing of having a chapter in my memoirs where I talk about having a doorstop made of solid gold. That's easily the most expensive thing in the room. Well, this isn't made of solid gold. This is made of high-grade aluminium that's precision milled. But I trusted a third-party manufacturer to get this done for me to make a head tracker, and it's beautiful, and it doesn't work. So there we are. There's two of those, worth more than my car. So whenever you're approaching a manufacturer, and to a lesser extent a contract engineer, you want to ask these four questions. First, is there anything in this project you haven't done before? Now, don't be shy. Tell me. What here looks risky to you? Have you done a flex rigid board before? Have you done something of this size before? And you want to find somebody who's being honest with you. If they're saying, yes, this is not a problem, this is zero risk, probably best to get a second opinion before you take that as read. So if there's something novel about this product they haven't seen before, will your entire life revolve around getting my project right? As a person whose livelihood depends on getting this out, I'm going to be working evenings and weekends, and I'm going to be throwing in 80-hour weeks in order to get this working. And I don't want to phone you up and find out that you first lied to me and secondly you've knocked off at 12 p.m. And you don't really care in order to get any more work done. I've got to pay you another check. I want you to take ownership of this. I want you to tell me how to solve your problems. I don't want to have to tell you how to do mechanical engineering. That's your competency, that's in-house. So will your entire life revolve around getting this project right? I'll speak more to that in the next slide. If no, do my trousers have really deep pockets? Am I willing to spend 5 to 10 times what it should reasonably cost to get this done? And then if no, does this fire escape lead to the car park? Now, of course, if you've got a contractor in, you're getting them out of the building rather than the other way around. But either way, I just don't work with people who don't have as much at stake at you. So now I'm going to talk about power and power asymmetry. And this is another thing that Matt Watkinson mentions in his book, that very often contractors are motivated by the dream to do a good job for other people, and that's fine. You know, we have our professional pride and our training. But very often what happens when things get very stressful, work gets very busy, order books get full, is what really matters in the end is just power. How difficult is this person going to make it for me if I delay the project? Because I've got these other things to work on that are worth so much more. And eventually it gets to the stage where if you're small and you're dealing with somebody big, they're going to think they're doing you a favor just by not hiding from the phone when it rings. So actually power asymmetry is a very important dynamic when you're doing something for the first time. And you need to find a supplier, if you're small, who's also small, who has as much at stake at shipping this as you do, who has almost as much to gain from making it work as you do. That's just a very important lesson I learned, and it cost me £4,000. And I'm glad I learned it before I did it later on in my career, and it cost me £400,000, for example. So, you know, it hurts a lot, but I got away quite lightly, I think. Next thing, and the final piece of advice, is to be lucky. Now, I say this because not all of us are going to start a company that makes hardware. Some of us work for companies that are going to make hardware, or work within organizations. And I'm saying this as a former employee who now considers himself unemployable. But it's a very important piece of advice that you can be lucky, that the hackneyed expression is if you find yourself the smartest person in the room, you're in the wrong room. And you have to ask why you're being barred from the better rooms, where you're the stupidest person, you've got all these people to learn from. But essentially, if you find yourself in a company that's operating a malicious fiction, where everything they do is brilliant and successful, or there's a huge burden of proof imposed upon you whenever you point out a problem, and other people just seem to be able to get their own way. If you find yourself in a company where you're an ambitious engineer, and they're growing so quickly that sales and marketing become the main engine of power, and there's absolutely nowhere for you to go. If you find yourself at the top of the tree and there's nobody to mentor you, but you feel you're being a bit held back, you can be lucky. What a venture capitalist can do is they can have a portfolio of 20 companies. You can only physically, bodily be in one building at once, working up, if you're lucky, on 3 projects. And so the only way you can make the best use of your time is to stay sensitive to times when things aren't going well for you and find yourself a better room. And when we're all at ADC, so we're probably all kind of upper quartile of people who do this because we've sought other people out to talk to capriciously during a pandemic and have these conversations with randomly. So that already bodes quite well, but you can be lucky. So we started with a kind of map of how this talk is going to go, and we finish with a set of abiding principles. And they are, firstly, just don't start. If you do, it's a bet, so set a stake, think like a venture capitalist. 3, let it take 2 years because it will take at least 2 years, particularly if it's your first project. Remove dependencies between electronics and mechanics, and also with software if you're doing that too. Reduce complexity, reduce size, reduce the quantity you manufacture. Reduce the friction of that agile loop, and reduce the budget that you spend every time you iterate. Find your people, don't find the wrong people, and be lucky. And I think, yes, I've managed to stay inside my time budget. So thank you very much. And also thanks to Anita for making this T-shirt and undermining my message, whilst also supporting it.
Craig says, don't or can't all digital synths and effects units converge to a common type of hardware platform? With sufficient processing power, memory, and interfaces, one unit can pretty well do any combination of sound modules and effects. We're already there in some extent with Daisy, Pedal Patch Field, Poly, Bibu, Zola, etc. So isn't the future software?
That's a good question. The short answer is no. And the long answer is I'd really like it to be, and things are, you're right, moving in that direction. People have started trying to do things with Raspberry Pi-likes and Linux distributions and get those into production. But very often the ways of doing things in software don't scale very well to hardware. With hardware, for example, you want to, if you're doing it with this set of priorities, and most people do, you want to maximize the amount of money you can make from each unit sold, so you're paring down cost. You're using the smallest processor you can that will work. Very often your user interface will end up bespoke because that's the whole point of making hardware. So yes, we do have this convergence, and maybe the platforms will one day simplify, but I've yet to see anybody pick a winner in that way. So for example, everyone's using an ARM, but depending on the complexity of your project, you might end up using an M3, an M4, M7, A8, A53. So many different processor families of different complexities, depending on what you're trying to do and what your margins can end up being. And then yes, and then the second point, of course, is you want to bolt a user interface onto that, and that will almost always be bespoke, because that's the value add of making hardware. But I largely agree that you can save prototyping time. And I would say that that's part of the decoupling works like and looks like. Your first prototype may use a Raspberry Pi, and it may use a really horrible Linux distribution that you wouldn't want anybody to see in a production unit, but it might answer the questions. It can certainly get you to your build 30 stage quicker. I think that's a comprehensive answer.
So the question is, how would you go about estimating the cost on a hardware project?
I would say that in every practical company I've worked for, 90% of the cost of a project is payroll. And the rest you can almost neglect, because it's going to take an engineer 4 weeks to make a project that's going to cost, say, £2,000 to put together. And that's going to be the most expensive thing they do. When it gets to the production stage, then things get more complicated. But by the time you get to the production stage, you're probably working out how much more you have to commit to make this real. And that's a different question you can ask yourself at a later stage. But I would say just take the number of hours you think you need and probably multiply it by 3. And that's the amount of budget you'll likely end up needing. The cheapest project I've ever done is my head tracker, because it was my time. And my time is effectively something I threw into this project. I didn't mind working 80-hour weeks for a couple of years. There was a lockdown. And that probably ended up costing me about £20,000 to £30,000 to put in production. And it's basically a cottage industry. I don't think you can do much cheaper than that. So the question is, I suppose, what are the implications, or do I have anything to say about the implications of the current supply chain disaster? I mean, for me, the implications of it are that I can't make any products for 2 years, so I'm 1 year into a 2-year hiatus. If you're at the bottom of the pyramid, it's a very lonely place to be, because bigger companies will just take stock and push you ever further down the queue. What I will say is I've been in this business 20 years, and I've never seen it this bad. So it'll probably be solved within the next 18 months when fabrication plants come online, when the supply chain sorts itself out. By the time your new product gets to market, it shouldn't be an issue anymore. But yeah, it's been horrible. Prices have increased to the extent that it's almost not worth making anything. But this is just a blip. In 20 years, I've seen this probably twice. The first time at the end of the 2007 crisis, when people started mothballing factories thinking that the game would be over for a year, and it wasn't, and so they got caught on the hop. That wasn't as bad as this crisis. The difference is that you could still go to Farnell or RS or one of the small part suppliers, and you could still buy 10 or 50 of the chips that you needed. And it was just when you were trying to buy thousands, you'd have to wait 6 to 9 months. This one is different. Everyone's got their supply chain software sorted out. It's almost like a dead man's handle buying things. And so as soon as one place is out of stock, everywhere else immediately gets out of stock, and you can't buy a single bloody chip. For a while, I was getting a little worried because I've got parts on back order from Farnell, and the shipping date went from September this year to January next year to January 2027, and now it's currently saying January 2023, and that's probably about where the law of averages say I might be able to build another set of head trackers. So I'm very grateful that when I mothball my company, I'm only mothballing one person. By the time you make a product, that should all be over. There are fabrication plants coming online. America doesn't like depending on China, so they'll sort that problem out too. So the question is, am I aware of, to paraphrase, any particularly interesting technological developments, any new chips or products that will make things cheaper or make things easier to develop? And I think I'll have to open the forum to that. I suppose I ought to mention, I think it's called Elk. There was a company that was, that for the last few years has been building an open source but commercial if you want to make money out of it. So sort of dual tier juice style license thing that is basically a powerful processor coupled to a very lightweight as possible Linux operating system so that you can port stuff onto it. Company's called Elk. That's worth a look, but I don't know if the metrics will be right to use it in production for everything. Otherwise, I've been concentrating on execution. I mean, I get angry when ST are sending me emails to advertise new products when they can't make the one I've been ordering from them for the last 18 months. It's a very French company thing to do, kind of progressing as if nothing is wrong whilst the whole world is on fire. I mean, these stereotypes exist because it turns out after trying to get things made that there's some truth in them. I'm not going to spend the next 30 seconds of my talk being racist because that'll be the end of my conference, but you know, dealing with a British company, all the cliches were true. I can see why people don't manufacture here, but I tried.